Hey, Neal from Tango Uniform here, and today we're going to talk about the Echo Zulu Castle Nut system, the easy way for you to quickly, safely, and consistently stake the castle nut on your AR. This is the long version of this video. We're going to go over all the components, the tools you need, do an install, and cover not only the how to do it, but the why we did what we did. If you just want to cut to the chase and get straight to the install without all the nerdy talk, check the description down below and there should be a link that goes straight to the install without all the BS. But hey, if you like to talk about guns, let's get into it. So why did we create the Echo Zulu Castle Nut system? The seeds of it start many years back in a conversation between myself and my friend James Yeager. I asked him what were the common failure modes on ARs going through his fighting rifle course. And he gave me a list, but at the top of it was castle nuts coming loose because they weren't properly staked. Now, this wasn't something that just happened on home builds, but it also occurred on rifles from manufacturers. I began to work at manufacturers and I began to understand why they were a little hesitant to stake the castle nuts. Because they could take a gun that was brand new, and if the armorer or gunsmith wasn't careful while staking, they could scratch that beautiful new gun. And then they would either have to sell it as a blem or disassemble it and reassemble it and start all over. So I can see why risk-adverse manufacturers might just want to pass that step on to the customer. So as I continued my career and I'm learning and growing, I've attended two of the most popular armorers courses in the industry right now. Excellent classes that I'll probably reference throughout this video. And one of the things I was looking for was the best way to stake a castle nut so that I could take that excuse away from manufacturers and home builders to not build their gun right. But what I found was there really wasn't a tool or a trick or a tip to do it right. All of the students, myself included, really struggled with that step. I scratched my gun in both classes. And so that's why we came up with this, so that you could safely, quickly, and consistently stake the castle nut. I know I keep hitting those points, but those were really why we wanted to do this. Now, if you're an armorer or a gunsmith who does this day in and day out, you may not care about some of these tools. You've already got your system down. However, we did make some improvements to the castle nut itself that may interest you. So let's get into the parts now. We're going to go ahead in this video and put an A5 buffer tube on this lower. Use that as our demo gun. So these are the components that I pulled off. This is the mil-spec castle nut that pulled off. I questioned the source of the receiver extension and the castle nut that came on this. But this was the castle nut that was on there. It's representative of what a mil-spec castle nut should look like. 4 wrench notches, 3 staking notches, and questionable threads. This is the Echo Zulu Castle Nut, and immediately you're going to see a couple differences. The first being that our wrench notches and our staking notches are collinear or in alignment. Back when the castle nut was first introduced, you really couldn't do that. This would have been what's called a multi-operation part in manufacturing, meaning they would have had a turning operation where they turned the outer diameter, cut the threads, and then they would have had to take it out of the lathe, put it in a mill, and cut the notches, making it pretty difficult to get your staking notches and wrench notches in alignment. Well, now, thanks to modern CNC manufacturing equipment, in particular a Swiss lathe, I'm able to make this all in one step, which means I can practically guarantee that that wrench notch and staking notch are in alignment. And you say, okay, well, who cares? Well, that allows me to create a tool like this, a staking guide that snaps into the wrench notches and then hangs over the staking notches, which will allow me to take a spring-loaded center punch and precisely start my stake in a consistent location every time. The other thing that you'll notice where we've deviated from the mil-spec is the number of wrench and staking notches. We went with 8. Why? Well, there's 3 reasons. 2 of them are kind of silly, and one of them actually makes a lot of sense. First, I just think it looks cool. I like it looking a little more aggressive there on the back of the rifle. The The second is what I call visual alignment. If you're a little OCD like me and you like things to be symmetrical, having 8 notches on there actually gives you 16 opportunities to achieve visual symmetry, because you can line it up on a notch at 12 o'clock or a blank space at 12 o'clock. Either way, it hides the asymmetry much better than a traditional mil-spec castle nut. And then finally, an actual good functional reason is that with a traditional receiver end plate and castle nut setup, the receiver end plate would be a disposable item. As you assemble this and you properly stake it, you've now timed all the 3 threads together on the receiver extension, and the castle nut. And if you disassemble it and reassemble it, even if you've changed out one of those components, it's probably all going to time back up to the same spot. So if I only have 3 staking notches with the mil-spec, or 4 in some aftermarket castle nuts, you're going to time back to the same spots. And so you're not going to be able to restake the end plate. You would have to throw this away and get a new end plate to stake at those same locations. Now with this, not really a big deal. This is a fairly inexpensive part. But when you start getting into some really nice aftermarket receiver end plates, like this Midwest Industries one that we're going to put on this gun, this one's my favorite. However, I've seen others out there that are upwards of $70 or $80 a piece. And so if I have to pull this apart to service the gun or replace a component, I don't want to replace an $80 component every time I do that. So by having these extra notches on here, even if it times up in the same location, I'd have at least 2 more points where I would be able to stake that end plate and reuse it. In addition to the features we talked about, we made this out of a 4140 pre-hard steel and did a long duration black nitride finish on it, as well as holding the tolerances on this to tighter than mil-spec for these wrench notches and for the threads on here to make sure that you got the best product possible. So that's the first part of the system. Next, as we mentioned, are the staking guides, and that comes in 2 different flavors. The first one that we came up with was an armorer's wrench. Now this serves a dual function, obviously. First being to properly install and torque your castle nut on, and then it has a steel staking guide here on this side. Now we knew that this wasn't something that a home builder might not buy. It's a little bit of an expensive part. So we came up with this option to go in the starter kit to be able to keep that affordable for everyone. We call this our bi-directional staking guide because it's symmetrical with staking guides on both sides. Now this, we paid to have the tooling made and it's injection molded. And once you pay for that tooling cost, it becomes a fairly inexpensive part to make, which allows us to put it in every single one of our starter kits. It's made from glass-filled nylon, which is the same material as all your popular polymer-framed handguns, so you know that it will hold up to a lifetime of abuse. The added feature that we found out after we did this was that if you're running one of the larger QD end plates back here, you don't want something that goes a full 180 degrees because it will limit the locations that the staking guide can go to. So this is going to be included in every armorer's kit because if you're running one of those real large QD end plates, it allows you to get all of the staking notch locations. Last piece of the puzzle is what we call the straight wall staking punch. This is included in every one of the starter kits. And then if you buy the armorer's kit, we include a spring-loaded center punch. If you don't buy the armorer's kit and you already have one of these that you want to use, or you buy it from somewhere else, all you have to do is unscrew this, don't lose any parts, pull out the old punch, slide the new one in. This is a 4mm diameter. It's a pretty common size for all the spring-loaded center punches on the market. And boom, now you're ready to go. Why is this important? Because most of the ones on the shelf have a little taper down here. And if you try to put it in here, you can see that that taper won't go in straight. With the straight wall, now it's going to go in straight every time. And that's the system. So let's talk about some other tools that you're going to need to properly install that castle nut on your AR lower receiver. First and foremost is going to be a way to torque it on. So if you don't buy one of our armorer's wrenches, you're going to need something like this, which is your standard car wrench. It's how I built my first rifle. Nothing wrong with this, but you notice there's no place to put a torque wrench on. So you're going to have to be doing it by feel. Or if you're building more than one rifle, investing in something like this, which is a Magpul armorer's wrench, it's a pretty good investment. You can see it has a spot to put a torque wrench on, but that spacing is for here to do the barrel nut. If you try to put a torque wrench on here and then do the castle nut, you're creating a lever and it's going to act as a force multiplier. So again, to use something like this, you're just going to have to be tightening it by feel. Good news is get it pretty tight on there, good and snug, and you'll be all right. But if you have our armorer's wrench or another manufacturer's armorer's wrench, then you're going to need a torque wrench to put on it. Why did we go with a 1/2-inch square drive instead of a 3/8-inch square drive? Well, you can see these two torque wrenches here, and the 1/2-inch square drive torque wrench is much longer. Why is that important? 2 reasons. First, the longer the lever, the more of a force multiplier it's going to be. And when you're trying to put 40 foot-pounds of torque on this castle nut, you're going to want all the help you can get. So the longer lever helps multiply your force on there. The second reason is gives you more fine motor control. So if I'm trying to rotate this 5 degrees, this handle spins a bigger circle, has a greater circumference that it has to travel to go the same distance. And so it's much easier for you to get the perfect distance on there. If you're only trying to travel a couple degrees, it's much easier to do with a longer handle than a shorter handle. Not as important back here, really important on a barrel nut or a muzzle device. Either way, it's a best practice whenever you're building a gun. So that's why we went with a 1/2-inch square drive on the armorer's wrench. One other thing, I like to use a razor blade to hold in the takedown pin spring. If you're worried about scratching up your gun, you can use a bench grinder to dull that edge, and really easy to press that spring in, and it allows you to get your end plate all the way up against the receiver before you pull it out. Finally, if you are not going to buy an automatic spring-loaded center punch and you're going to want to do this with a hammer, you can do that. You can use the staking guide and hit the head of this with a hammer. However, I would recommend you not start with a larger hammer. This is a 1.5-pound ball peen hammer, which is great for finishing with when you're trying to move a lot of metal. But in the beginning, when you're trying to get the location started on the stake, I would recommend using an 8-ounce hammer like this. This is a gunsmith's hammer purchased from Brownells. I've got a bunch of them. If you're going to be working on guns, this is something you should invest in. It's got Delrin on one side, brass on the other, so that you don't beat up your guns, but it allows you to get much better motor control to get the stake started, and then you can come back with something like this to actually move metal. And don't go and get like your 5-pound baby sledge and wail on this. That's way, way too much. This is plenty. And then finally, how we're going to hold the gun while we're working on it. In the instructions, I recommend using something like this. This is a jig that holds your lower receiver and your receiver extension. This bolts in here. Your receiver extension goes back through here, and it keeps that receiver extension perfectly timed while you're tightening everything down. If you're going to be building a lot of guns and you're a little OCD like me, it's probably a good investment to have. Not necessary though. And for the purposes of this video, because we want all the cameras to be able to see what I'm doing, I'm just going to go ahead and use a Magwell vice block to hold this down. Everybody, again, if you're working on ARs a lot, a solid, good Magwell vice block is invaluable. Get one that, as I said, is literally solid. The ones that are injection molded have to be honeycombed to get a uniform wall thickness, and I've snapped many in half when working on guns. Get you one that's solid, and get you a good bench-mounted vise. You should have this in your shop anyways for doing all your projects. That's the easiest way to work on a gun. Last but not least, let's talk about Some chemicals. So this is Aeroshell 64. This is what the mil spec calls for when assembling components. Why does it call for this? Well, two reasons. First, we're marrying components of dissimilar materials, in particular aluminum and steel. And if you have aluminum and steel against each other, and then you introduce water, you get what's called galvanic corrosion. This is what happened with the rifles in Vietnam. It's what happens in an engine where you have a cast iron block and an aluminum water pump. It's not good. So by using grease as you're marrying those components together, you create a barrier that the water can't get through to create that corrosion. The second and more important reason is to get an accurate torque value as you're tightening this together. If the parts can't move freely against one another, in particular aluminum will do what's called galling. If the aluminum galls up, it may feel like you're putting 40 pounds of force, but it's really not getting those components where they need to be, and then they will vibrate loose over time. So that's why anytime you're torquing something down, you want to make sure that you have something on the threads to help them move together. Now, in other applications, you can use Loctite, Rockset, Vibratite. Those will help the components move while you're torquing, and then will harden up and not allow those parts to come apart. We don't want that here. We want to be able to service this gun if necessary. The exception to that rule being, if you have concerns that some of your components, like these that we pulled off of here, came from a questionable source, if you think they're hobby grade instead of duty grade, then you could use some Vibratite. Chad at School of the American Rifle says Vibratite will overcome one class of threads. So this is supposed to be a class 2 thread, this is supposed to be a class 2 thread, this is supposed to be a class 3 thread. And if you feel that any of these is lacking, you could use Vibratite to overcome that. But I will tell you, it makes the rifle a pain in the butt to take apart. I would recommend that you just buy quality components from trusted vendors and good sources and not worry about that. I purchased this from Amazon. It's more than any normal person should need. And so if you're looking to get smaller quantities of this, or cold blue, or Loctite 620, or any of the specialty chemicals that are a little more difficult to find, again, School of the American Rifle sells those in enough to do 2 or 3 rifles. And so for like $20 plus shipping, you could get all of the chemicals you need to do a whole gun. That's where I would check out. So again, besides the grease, a little cold blue, this is not necessary. It's just to cover the exposed metal on the end plate when we're done with the staking. So that's everything you need to do this process. We've talked about the parts, we've talked about the tools. Let's get to putting this gun back together. Okay, so step 1, which we've already done, would be putting our straight wall staking tip in our automatic center punch. If you didn't purchase it already installed, go ahead and get that put together. Step 2 is going to be putting grease on our components and then beginning to install the components. Now, you don't have to go absolutely crazy on the grease. A little bit on the ends of the threads. As you assemble it, will push that grease down into the remaining threads. Okay, throw a little in the receiver. The other place where you want to make sure you put a little grease is going to be on the flats between the castle nut and the end plate. Again, we don't want those staking notches to dig or gall on there. We want it to move freely. And again, because these are quality components from trusted vendors, I can feel that this end plate and this castle nut feel good. There's not a ton of play in there as opposed to the components I took off. The end plate rattled quite a bit. and the castle nut rattled quite a bit on there. I also like to use grease in all of my lower parts kit components as I'm putting it together. It does two things. One, we're pre-lubing the gun as we assemble it, like I just did on that takedown pin slot. But the other thing is, if you somehow lose control of this, it is going to prevent the springs and detents and everything from shooting off in crazy directions. Everybody has done that at least once, where they had the spring and detent take off. The other thing I'm doing right now, I'm using my spring to push my detent in, and I'm making sure that that detent has found the slot in the takedown pin. And you'll see me check that a couple times, because there's nothing worse than getting everything perfectly torqued and staked and amazing, and you pull on that pin and it comes apart and you're doing it all over again. Again, grease on the springs, grease on the detent, and that will keep that guy from flying if you have to take it out. So buffer retainer in there, I've tightened this until it's retaining it, and then I come past right there. So I'm holding my buffer retainer in, grease on my takedown pin detent spring, slide that guy in there, razor blade, push that guy in, slide my end plate over, and before I even pull the razor blade out, I'm able to get that end plate in there. Boom. Now it's on there. Visually confirm that you don't have any coils of that spring between the end plate and the receiver. Hand tighten that guy down, and you're in the home stretch. Next, we're going to go ahead and torque the castle nut down. I like to put the flat side of the wrench towards the receiver. The staking guide should clear on a mil-spec forging, but sometimes you guys are going to have a billet receiver that might be reinforced in this area, so we don't want the tower for the staking guide to come in contact with the lower receiver. Slide it on there. Make sure that all three teeth are engaged. I like to use my non-dominant hand to pinch this together to make sure it stays in place. There you go. And this, I said off camera, this is at 38 foot-pounds of torque. I'm fine with where that timed out. You could crank that up to 40 or 42 if you felt like you needed to get it to go a little further. The other thing you could do is called seasoning the threads, which would be loosen it and tighten it, loosen it and tighten it. Not as critical in this application unless you're trying to get it to rotate a little further. It's a lot more important when you're pinning and welding a muzzle device or something like that. So now that guy's properly torqued on there, and we can move on to staking. Because this Midwest Industries receiver end plate has a QD mount sticking out, I'm going to go ahead and use the bidirectional staking guide to clear that. Now, the TDP calls for this to be staked in 2 positions. I would recommend trying to stake them at opposite sides. If you do them up next to each other, you're kind of pushing the castle nut, off on one edge. So put them ideally at 3 and 9 o'clock if we're looking at this like a clock. So somewhere like right here. So the other critical thing is that when you're putting either of the staking guides on, that you fully engage it in the wrench notches, and it should come flush with the back of the castle nut. If you see that it's sticking out like that, either there's something in there that's preventing it from going in, or you need to push it in there. It's important that all of the teeth fully seat in, and the way you can tell that is by looking to see that those tabs are flush with the back of the castle nut. A lot of times I'll just hold this in my hand with no buffer or buffer spring installed. I can put a finger down there and pinch this just like that with my thumb to hold that in place. Spring-loaded center punch. Slide that guy in there. Now, there's a little bit of wiggle to it. So which direction do I want it to point as I'm staking it for the first time? I want to angle it with the point towards the receiver. I want to have as much material there as I can to deform into the staking notch. So angle this, if you have a choice, angle it towards the receiver. Not crazy, I'm still keeping it straight here, but just angle it a little bit towards the receiver. And there you go. Pull your staking guide off. Take a look at your notches. This is my opportunity that if this is a little off center of the staking notch for whatever reason, then I can take my punch and I can angle it in the direction that I want it to go. I can drive the metal in the stake in the direction I want to go. So I want this to go a little counterclockwise till it's center with the notch. And then once I have it dead center in the notch, then I'm going to angle it so that I'm driving metal into the staking notch. And there you go. Our first stake is done. The intention of doing this is to push metal from the receiver end plate into the staking notches. That's the intention, is that as your buffer and action spring come back and your buffer bumper hits on the back of your receiver extension, it's pulling this back like this, and you don't want it to eventually work this castle nut loose. So by deforming the metal into that notch, we've mechanically locked this in place to prevent that failure mode. Again, you don't have to go crazy with the amount of metal you move. This is plenty. However, it's not going to hurt it. Like I said, you saw how many punches I did here, about 10 to 12. But if you want to sit here and really go to town on it, you're not going to hurt anything. Again, this is the safest, easiest way to do it, as long as you make sure that the tip is engaged in there before you get started. You can keep going until that stake is nice and big. So again, we're going to come over on this side, and I'm going to do less talking and more action so that you can see really how quick it is. There you go, done. Safe, quick, and consistent. Again, I'm not going to do it here, but if I wanted to cover up that raw metal that we've now exposed with the stake, you just use some cold blue and put it on there. I would want to degrease this first before I put the cold blue on. So some acetone would work great to do that. Then once you've applied the cold blue and gotten the finish that you desire, you have to make sure that you neutralize that with water. It's a acid, essentially. You're creating rust that's black, and if you don't stop the reaction when you've achieved your desired result, you'll come back and found that it's grown into red rust. So get the finish you want, neutralize it with water, and then dry the water and add some type of lubricant to protect it. I've been playing with this Seal 1. It's excellent for all the different components of the gun. You don't want to go crazy when you're cleaning your guns and degrease them and take away the protective layer we've put in the threads there. People overclean their guns. Wipe them down and put a good sealer like this on there, and you'll be good to go for a lifetime of use. Pretty painless, right? Thank you so much for purchasing one of our Echo Zulu Castle Nut systems. Please tag us on your social media of choice to let us know how it's working out for you. Again, I'm Neal for Tango Uniform, and remember that luck favors the prepared. Have a good one.